In this video, we will practice using trigonometric identities to rewrite expressions in equivalent forms. This is AP Precalculus Topic 3.12. If you appreciate the content, please give it a like. In a previous video, we learned all of these wonderful trig identities. Pause the screen and practice writing them down on scratch paper from memory. On the AP exam, no formula sheet will be provided, so you will be expected to know these by heart. Break out those flashcards. From this point forward, I'm going to assume that you have all of these memorized. I'm going to assume that you know these basic trigonometric identities as well. So make sure you do. Simplify the following expressions to one of the answers in the box. Answers may be used more than once, and some answers may not be used. Show all appropriate work that leads to your answers. Secant squared theta minus 1 reminds me of the version of the Pythagorean identity that goes like this. Tangent squared theta plus 1 is equal to secant squared theta. If we subtract 1 from both sides, we get tangent squared theta is equal to secant squared theta minus 1, which is exactly what we see right here. So really, that's it. We can just replace this with tangent squared theta. Now let's look up and see what we've got. Haha, E. So the answer to number 1 is E. Number 2, sine squared theta minus 1. This reminds me of the main Pythagorean identity that goes sine squared theta plus cosine squared theta is equal to 1. Since the given expression has sine squared theta in it, let's isolate sine squared theta here and get an expression that we can substitute in and see what happens. Subtracting cosine squared theta from both sides gives us sine squared theta is equal to 1 minus cosine squared theta. So now let's make that substitution. So instead of sine squared theta, we will have 1 minus cosine squared theta. And then we still have the minus 1. Notice that we have like terms of 1 and then minus 1, which cancel each other out. This will leave behind negative cosine squared theta. Let's see if that is one of the things in the box. It's right there. Answer J. For number 3, I'm going to fall back on our favorite strategy, which is to rewrite everything in terms of sine and cosine. Cosecant theta can be written as 1 over sine theta. Tangent theta can be written as sine theta over cosine theta. And then secant theta is 1 over cosine theta. Now I'm noticing that we have a sine theta in the denominator and sine theta in the numerator, which will cancel each other out. On the next step, we have 1 over cosine theta minus 1 over cosine theta. Obviously, if you have anything minus itself, that is 0. So let's see if that's one of the options. I was losing hope for a second. The answer is G. Number 4, cosine squared theta times 1 plus tangent squared theta. One version of the Pythagorean identity says tangent squared theta plus 1 is equal to secant squared theta. So let's make this substitution. We will be left with cosine squared theta times secant squared theta. You know how cosine theta and secant theta are reciprocals of each other? When you multiply cosine theta times secant theta, you're always going to get 1. And it'll be the same if you multiply cosine squared theta times secant squared theta. So if you happen to notice that, you can just skip to the end and just say, oh, the answer is going to be 1. If you don't notice that, then you have to go through the motions of writing cosine squared theta times 1 over cosine squared theta. And then you go, oh look, we have cosine squared theta in the numerator and the denominator. These cancel out and leave 1. That's C. For number 5, let's use our favorite strategy of rewriting everything in terms of sine and cosine. Cotangent theta can be written as cosine theta over sine theta, and secant theta is 1 over cosine theta. Notice that we have cosine theta in the numerator and in the denominator. These will cancel each other out, leaving behind 1 over sine theta. But we all know that 1 over sine theta is cosecant theta. And that's B. In number 6, be careful not to think you can cancel out the sine or the cosine. Because of the addition and subtraction that are happening in the numerator, you can't cancel out anything. Also, this binomial is being squared, so you can't cancel out from the inside of something that's being squared anyway. So let's expand this. Sine theta plus cosine theta is sine theta plus cosine theta times sine theta plus cosine theta. Minus 1. That reminds me of another thing I need to warn you about. A common mistake is to think that in order to square sine theta plus cosine theta, you can just take this little 2 and distribute like this and write sine squared theta plus cosine squared theta. And then maybe you know that, oh, that's 1. So some kids would do that. And then you would say, oh, I've got 1 minus 1, that's 0. And you would pick the answer that says 0. That's a whole lot of bad algebra. You cannot square a binomial by squaring each part individually. That is bad algebra. Instead, you have to multiply it by itself. You have to FOIL this, or you can think of it as doing the distributive property twice. So let's see. Here we go. Sine theta times sine theta is sine squared theta. And then sine theta times cosine theta is sine theta cosine theta. I'm leaving extra space here, and I'll show you why in a second. But for now, we have sine theta cosine theta. So I have distributed the sine theta. Now I am distributing the cosine theta. Cosine theta times sine theta is sine theta cosine theta. See how I already have one of those? Instead of writing it again, an extra sine theta cosine theta, let's combine these like terms. And that will be 2 sine theta cosine theta. So that's why I left the extra space, so I could put the 2 here. Now we multiply cosine theta times cosine theta, and we get plus cosine squared theta. And this is minus 1 on the end, all over sine theta cosine theta. Let me remind you once again, we cannot cancel out the sine theta or the cosine theta because of all of the addition and subtraction. So resist the temptation to do that. However, notice that we do have sine squared theta plus cosine squared theta. We have learned that sine squared theta plus cosine squared theta is equal to 1. That is our favorite Pythagorean identity. So let's make that substitution. So we will have 1 plus 2 sine theta cosine theta. And then we have the minus 1 on the end over sine theta cosine theta. Next, the 1 and the minus 1 cancel each other out. So we get 2 sine theta cosine theta over sine theta cosine theta. Guess what? I know you've been dying to do this. Since there is no more addition and subtraction in the numerator, we actually can cancel these out now, leaving behind simply 2. The answer is K. On your exam or the AP exam, the directions will say, show all work that leads to your answer. It's important that you do not skip steps. You need to show every step, just like I'm doing, one step at a time. And the grader has to be able to follow your logic to the answer. For number 7, we could use the strategy of rewriting everything in terms of sine and cosine. However, I'm noticing a special case here. Tangent and cotangent are reciprocals of each other. Secant and cosine are reciprocals of each other. So I'm going to use that fact to help me simplify. Let's split this fraction apart by pulling the secant theta off to the side on its own and pulling the tangent theta also off to the side on its own. So we will have tangent theta off to the left, leaving behind 1 over cotangent theta. Minus, if we pull the secant theta off to the side, it will leave behind 1 over cosine theta times secant theta. But the reciprocal of cotangent is tangent. So I can replace this little fraction with tangent theta. That will give me tangent theta times tangent theta. See how I am not skipping this step. Show this step. 1 over cosine theta is secant theta. So we have secant theta times secant theta. So you might have seen this coming, and it might have been tempting to skip to tangent squared theta minus secant squared theta. But don't do that. Show this middle step. One version of the Pythagorean identity tells us tangent squared theta plus 1 equals secant squared theta. So we can replace secant squared theta with tangent squared theta plus 1. Be careful, when you make this substitution, you're going to need parentheses because of the negative sign in front. So we will have tangent squared theta minus parentheses tangent squared theta plus 1. Now we will distribute the minus sign, which gives us tangent squared theta minus tangent squared theta minus 1. Of course, tangent squared theta minus tangent squared theta cancels itself out, leaving behind just the negative 1. So the answer is A. Number 8, sine and cosecant are reciprocals of each other. If you notice that, then you know that sine theta times cosecant theta will automatically equal 1. If you don't notice that, then you need to go through the extra step of writing sine theta times, and then cosecant theta is 1 over sine theta. And then you say, oh look, We have sine theta in the denominator and sine theta in the numerator. These cancel each other out and leave 1. So the answer is C. But again, a trig function times its reciprocal will always equal 1. So if you ever notice that you have a trig function times its reciprocal, it's okay to just go ahead and skip to putting 1. Let's rewrite number 9 in terms of sine and cosine. In the numerator, we can keep the cosine theta, but in the denominator, secant theta can be written as 1 over cosine theta. When you divide by a fraction, you multiply by the reciprocal. So we have cosine theta times cosine theta over 1, but I'm not going to put the over 1 part, it's unnecessary. And of course, we now get cosine squared theta. The answer is L. For number 10, I am going to use the strategy of rewriting everything in terms of sine and cosine. So we have 1 minus sine theta, and I think I will write sine theta over 1. Cotangent theta can be written as cosine theta over sine theta. And secant theta is 1 over cosine theta. Interesting. We have sine theta in the numerator and the denominator. These will cancel each other out. And we have cosine theta in the numerator and the denominator. These will cancel each other out. So we are left with 1 minus 1. Everything that cancels out is making a 1. Of course, 1 minus 1 is 0. So the answer is G. Once again, I'm going to rewrite everything in terms of sine and cosine. That is our favorite strategy. Cosecant theta can be written as 1 over sine theta. Secant theta is 1 over cosine theta. And then tangent theta is sine theta over cosine theta. I want to have like denominators. I think I'd like to go ahead and combine these fractions into one big old fraction. In fact, I guess I'll show this on a separate step. It feels a little bit silly, but I can put these together as 1 over sine theta cosine theta. This is probably a step that you could skip if you wanted to, but I'm going to show it for instructional purposes. Now, I want like denominators. Both denominators already have cosine theta, so I don't need to do anything to make that happen. The fraction on the left has a sine theta. The fraction on the right doesn't. So I'm going to multiply the fraction on the right by sine theta over sine theta. Now we have a common denominator. So we can combine these fractions into a single fraction using the common denominator. In the numerator, we have 1 minus sine squared theta. In the denominator, we have the common denominator, sine theta cosine theta. At this point, you have seen this often enough that you probably recognize that 1 minus sine squared theta is cosine squared theta. However, if you need to write the Pythagorean identity to help you understand that, here we go. The number 1 identity is sine squared theta plus cosine squared theta is equal to 1. Subtracting sine squared theta from both sides gives us cosine squared theta is equal to 1 minus sine squared theta. So, you see we have the 1 minus sine squared theta in the numerator. this will be equivalent to cosine squared theta. Now we have this. The cosine theta in the denominator will cancel out one of the factors of cosine theta in the numerator, leaving behind cosine theta over sine theta. Of course, cosine theta over sine theta is cotangent theta. The answer is I. For number 12, I will once again use our favorite strategy of rewriting everything in terms of sine and cosine. Cotangent theta can be written as cosine theta divided by sine theta. And then cosine theta, I'm going to write as cosine theta over 1 plus sine theta over 1. So multiplying these two fractions together, we have cosine squared theta over sine theta plus sine theta over 1. Let's get like denominators so we can put these together. We need a sine theta in the denominator here, so let's multiply the fraction on the right by sine theta over sine theta. On the next step, we will have cosine squared theta over sine theta plus sine squared theta over sine theta. Now we have like denominators, so we can put these together. And we will get cosine squared theta plus sine squared theta over sine theta. What do you notice? The Pythagorean identity tells us that cosine squared theta plus sine squared theta is 1. So this will become 1 over sine theta. And 1 over sine theta is cosecant theta. So the answer is B. One more time, I want to caution you not to skip steps. You might have seen it coming that we had cosine squared theta plus sine squared theta, and that's always equal to 1. Some of you are very comfortable doing a lot of steps in your head. But this is not about getting to the answer. It's about showing your logic to the grader. So you cannot skip straight to here, or if you're very clever, you might have seen it coming, and you might have wanted to go all the way to here. You will not get full credit for that. You have to show, one step at a time, how the problem logically evolves from this to this. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.